Hello, everyone, and welcome to the Drand workshop. Hooray! Drand is used in Filecoin. It's the thing, the service or the system that provides randomness that Filecoin relies on for things like leader election, which is kind of important. But Drand, what is it really? Let's just get back to that. Here we go. Drand. So it is a group of Drand nodes basically collaborate together to generate randomness. And they do that on a period of around 30 seconds. And that randomness is verifiable, unpredictable, and unbiased. And it's done as a service, so anyone can consume it. It's public, including Filecoin, and it does. So the Drand members of the League of Entropy group. This is the group that are currently running. Each one of these organizations are running a Drand node, and every 30 seconds they are generating new randomness collaboratively. And you can see down here the latest randomness that is happening, and you just saw it quickly change as it updated. We're currently on round 265,048, and in 16 seconds there will be another round generated by these guys. Anyway, now that you know everything about Drand, well, okay, there are many details that I just missed out, but we're going to talk today about the Go and JS clients, and we're going to use them to get hold of some of that box fresh randomness from the Drand nodes that this League of Entropy will run. And so today we're going to be mostly getting randomness using the HTTP JSON API. And there's going to be live coding. It's going to be mostly live coding, so you can try and follow along. I'm going to go really fast, but you know, it's a workshop. I'm going to live code it. Things are going to go wrong, but it's going to be exciting and it's going to be fun. So let's get on with it. All right. First of all, we're going to try and get some information about the chain of randomness that League of Entropy are generating every 30 seconds. And so what happens is that Drand produces a chain of randomness, and each new beacon points to the previous beacon all the way along to the genesis. And so the chain, the kind of information that we're interested about in the chain is the period between randomness generations, the genesis. So when the chain started, if we know the period in the genesis, then we can predict exactly when the next round of randomness is going to be generated. But also the public key, which is useful for verifying the rounds are the rounds that we expect them to be. So let's go. Let's head over to the docs. So you can see on this website, if you head over to developer, then we've got client library documentation here. We've got one for Go and JS at the moment. But what we're going to do is, first of all, we're going to grab the chain hash from this page. You can copy it from the page and head on over here. I've got a new project here in my, it's a new Go project. I've got a main.go files, not much in there at the moment. I've got my Go mod. I've already got the Drand module from Drand/Drand, and that's in there, that's ready to go. So in here, I've got just a main function, just with just printing out done when it's done. And I've set up two variables here. So we've got a constant chain hash. I'm going to paste in that chain hash here, and the chain hash. Let me talk about the chain hash for a minute. The chain hash, it's uniquely identifies the chain. And it is the SHA-256 hash of the public key, the genesis time, and the period. So what will happen is that this client that we're creating, it will ask the chain for that information, and then it will hash that information and compare it with the chain hash that I've just pasted in here. And if they're the same, then we know that the chain that we're talking to is the chain that we expect to be talking to. So it's very important that we use this chain hash or directly give the client the chain info, so that we know we're consuming the right randomness. And then URLs. Here we go. We can copy these off the website too. The League of Entropy, some of the League of Entropy members, they have publicly accessible HTTP APIs. There are also protocol run gossip sub client relays that you can use in libp2p gossip sub. We're going to use the HTTP APIs today. So I'm going to copy, so PL run this one here and Cloudflare run this one here. I'm going to copy these in. So we've got two URLs there. I'm just going to uncomment this. So all we're doing here is that we've got our chain hash. It's hex encoded. We need to give it to the client as a bunch of bytes. So we're just decoding that hex string into some bytes. So that's all that's going on there. What's next? Let's create a client. Here we go. Okay. So C and then possibly an error. I'm just going to ignore errors in this this demo and hope that none occur. Okay, so client, we need a client. We're going to use client.wrap today. And so what my editor's done here is it's just imported the Drand client package for me. And I've got this wrap function, and that takes a bunch of clients. So this is really interesting because what the Drand client does is it wraps multiple concrete implementations. So we're going to use HTTP clients today, but like I said, there are libp2p gossip sub clients, and there's also a Twitter client because randomness is also being tweeted. Where have I got? Here it is. It's being tweeted to this League of Entropy mainnet thing. So that's super cool. Let's get back to the code. So we've got this client wrap. We're going to use the HTTP client and 4 URLs. So it's what's happened here is that my editor's imported the HTTP package for me. We use 4 URLs, and we're going to pass that the URLs that we've got up there, as well as the hash that we decoded. Just gonna save. So there we go. And we're going to use an option which is client.with chain hash. Perfect. Okay, so now we have a client. We've instantiated our client. We've got two HTTP clients in there, and we're passing it with chain hash option. I did mention about the chain hash. We should pass it. There's an option to use insecurely, which will mean that the Drand client doesn't do any verification of the Drand rounds that it sees, and you should only use that in testing. Don't use it in a production service. Otherwise, use the chain hash. All right, so clients, this is what the interesting thing about this client is that it will wrap all of these clients that you give it, and you can consider them as one single client. And it wraps these clients, it does the round verification for you, but it also does special things like it speed tests the client. So every so often it will speed test each one of these clients, and then when you ask for some randomness, it will use the fastest one. And if that fastest one doesn't respond for whatever reason, then it will move on to the next one. It's got failover in it. It's amazing. So there's all of that goodness in there, and you should totally use this client library that we've built, if possible, because it provides these amazing things. All right, let me just check that I've told you everything I wanted to tell you. It also does caching. Forgot about that. Yeah, if you ask for a Drand round, then and you ask for it later, then you don't have to go and get it again. So that's also good news. All right, so now that we've got our client, we've instantiated it. What can we do with it? Well, I'm going to get hold of that info because I've said that's what we're going to do. We're going to get hold of the info. So info, possibly an error. Let's not worry about that. It takes a context, so you can cancel it if you like, but what this will do is we'll get hold of the info for the chain. So I've got a handy snippet over here. Here we go, and that I'm just going to copy and paste that because this would take ages to type out. But all that we're doing here now is we're going to print out some of that information that we get. So we've got the public key there, as I said. That's just being printed out as it comes. The genesis time for the chain. This is in seconds since the Unix epoch, and what we're doing is just whoa, what happened? Okay, there we go. Don't worry, don't panic. It's okay. This is the genesis time since the Unix epoch in seconds, and we're just making it into a Unix. Let's just save that so it stops complaining. Yep, making that into a Unix timestamp and then printing it out so we get something nice printed out. The period, as I said, for mainnet on the League of Entropy nodes is 30 seconds. So I'm expecting 30 seconds to be printed out here. And then we also have the hash in the info, and we're just going to encode add that to hex so that we can compare that with that hash we got up here. And we'll see that they are the same. They should be the same. Let's hope they're the same. Let's run it. Go run main. All right. Okay. So here we go. We've got the public key. That's there. Genesis time. That is June, July, something like that. 1617. That's when it happened. The period is 30 seconds, like I said. Rad. And the chain hash is the same chain hash as we've got up here. All right. It's working. Hooray. Okay. But this isn't interesting at all. You know what's interesting? Actually getting randomness. And this is just the information about the chain. So let's get some randomness. Let's get the latest random value that has been generated. Latest we can use for that purpose. There's a function called get, and this allows you to get the latest randomness value. Use some context, and what we need to do is give it a round number here. And so every time we dround generates a new round, it's given a sequential number, but we don't know what the latest round is. But well, I could look at the website, but we don't know usually. If I pass 0 here, then it will just give me the current round, the latest round that has been generated. So let's pass 0 here. Hooray. Okay, and then I've got a handy, I keep pressing the wrong button. I got a handy snippet here, which will print out that round information. So here we go. And all we're doing here is we're printing the latest round. That's the round number there. That's very cool. And the actual randomness that was generated, and we're just going to encode it as hex because that makes it easier to look at in the terminal. All right, so let's save that and we'll run it. Here we go. So let me move up a little bit. Okay, so we had the public key, Genesis period, the chain hash. We've got the latest round. Here we go. This is what we're looking for, is 265,068. We've got BEB, latest randomness. If we check that against the website, we should have, every time I try this, it changes out from under me. Okay, here we go again, one more time. 265,069 and 67 BC. So 265,069, 67 BC. Yes, great, cool. So we are getting the latest randomness, which has also been verified by our website. Perfect. That's great. What about historical randomness? We can get that too. So let's get some old randomness, because why not? I'm just going to copy that wholesale from that. There we go. Old round. It's an old round. And we're going to get, what round number shall we get? 1, 2, 3, 4. Good idea. Good idea. All right, let's run that again. Old round 1, 2, 3, 4. Out it came. Perfect. And that looks like the randomness as I remember it from that time. If I run that again, then I should get the same thing because it's the same round. It's always the same. It doesn't change. It doesn't change. So that's great. Old randomness. Perfect. All right. I've done some things. What should we do now? Let's. So the other thing that you can do in the client is you can watch for randomness. So you can get the fire hose of randomness right into your eyes if you so wish. And you call the c.watch function. And this gives you back a channel. And so I can use a for loop on the channel because why not? Rand. I'm going to call it rand. Range. You can range over that watch channel. And what this will do is it will give me the latest round. Oh, I need some context. Let's put the context in there. It'll give me the latest round. I'm going to say new round. Okay. Oh, no, I didn't call it new. I called it round. There we go, round. Perfect. So this is a new round that has come in, but what watch will do is it'll give me the current round first. So I'm expecting to see like the latest round here, and I'll see it copied again just here and printed out. And then it will stay watching. I'll stay in this loop. And when the next round comes out 30 seconds later, so let's run this quickly. Helps if I save it, doesn't it? There we go. There we go. All right, okay, so let's have a look. We've got the latest round, new round. So this is the latest round here. And so what will happen is that when after 30 seconds elapses, then a new round of randomness will be generated, and that will be delivered on our channel to our program, and it will print out the next round. So there it is. Hey, hooray. That's great. So we got round. You'll notice that we didn't, the program didn't finish. We didn't get our done printed, and that's because we haven't finished we're still in the loop. We're still watching for randomness, and we can't get out. How do we do that in Go? People who use Go are all like, just use the context. You can use the context, and you can cancel the context. And when you cancel the context, it will stop the watch from watching. So fun times. Cancel that, and let's have a quick look at that, just in case you're not familiar with context. Okay, there we go. Context. So instead of passing this background context here, we pass in our special context, which we created from the background context, but it has a timeout, and we're saying after 30 seconds, just stop. Cancel the context, so it will be cancelled. So what I'm expecting to happen here is that I'll get the current round, so 26577, the latest round, and then I'll get 30 seconds, well, less than 30 seconds-ish later, we will get the next round as it's generated, and then after this 30 seconds elapses, then this context will be cancelled. We will exit the loop, and our done will be printed. So, okay, now we just got to awkwardly wait. There we go. Okay, that was quick. Perfect. So yeah, we got, I expected exactly that. So perfect. Hooray. That's how you derand client in Go. All right, this is going well so far. How are we doing for time? 16. Okay, perfect. All right, we've got loads of time. All right. What should we do now? Yeah, okay, let's make this. So that's fun, and you can use that in your Go applications and stuff. But what we should do now, seeing as we've got so much time together, and it's been fun so far and nothing has gone wrong, let's make a web application. Yeah, let's do it. I've got this Drand dice roller thing. I've got a repo here, so if you want to clone it and look at the code, then you can go ahead and do that. But let me show you it. Let me show you it. Okay, here it is. I started it up there. Here it is. Okay, it's a dice. It's a 20-sided dice or die. Okay. Anyway, so dice, whatever. Roll a dice. If we roll a dice, 4. If we roll a dice again, 4. Okay. All right. So this is great. This is great. This is actually a expected, because this is a 4 roller dice. This rolls the number 4. Guaranteed randomness is broken. It's broken, isn't it? So here we go. We've got the dice roller. This is the HTML. This is the code. This is the dice. It's a div, and it has the current rolled value in the middle. We've got a button. We've got some style. You don't care about the style. We've got a script with which is a module, and that's cool. Let's go and have a look at this code. All right. Okay. First of all, what we do is we import this roller.js file. I'm not going to open that file because it's not really interesting, but what you need to know is that you start the dice rolling by calling roll, and it keeps putting different numbers in the dice, and it will keep doing that forever and ever and ever until you call stop. And when you call stop, you give it a number to settle on, and it will stop the dice then with that number. All right. Let's have a look at what's happening in the main function. So we just call this main function. So we get the dice element. We get which is that div. We get the roll button, and we attach an event listener to the roll button, which calls that roll function. It's saying start the dice rolling. Okay, great. And then there's a set timeout here after 5 seconds, as you can see just there. What it will do is it will tell the current roll to stop on the number 4. And that's how I knew it was going to be 4 every time. Okay, so this is broken. What we're going to do is we're going to create or fix this application to use Drand as the generator of randomness for the random dice rolled number. All right, so how do we do that? Good question. First of all, we need got this handy snippet so I don't have to type this out. We need the Drand JS client. Drand.js client is really similar in its API to the Golang client on purpose, so you feel right at home when using it. So I've imported it here. We've got the client as we did in Golang. We've got HTTP, which is the HTTP client. And then I've got this snippet. This is the chain hash and the URLs as we had them before, as you will remember from the Golang part. The chain hash, here it is, the URLs that we were using. That's cool. And then what we're going to do, we're going to instantiate the client. So I've got this here. Okay. So I need an async on this function now. Async. There we go. So we're using client.wrap again. We're using http.for URLs, so this creates a bunch of clients, and then it gets wrapped by the big client that does all of the optimization and verification and caching and all sorts. So awesome, same thing, easy to do. And so with that client, what we're going to do is instead of this set timeout, we don't want that. Let's get rid of that. And what we want to do really is replace this number 4. Hang on, we need an async up here. We're going to replace this number 4 with a random number from Drand itself. Cool. So client.get. So we can await client.get. And what we want is the next round. So we don't want the current round. We want like that, but that's not what we want. So luckily there's an API for this, so we can use client.roundat. This also exists in Golang. Date.now. And so what this is doing is it's saying, give me the round number when it was this time. So by putting date.now in, we're saying, give me the round number right now. So the current round number. It could be computed because we know the genesis and the period. So that's great. We don't have to go and get that round. We just compute it. Next round num. So this will give us the current round, but actually we want the next round, because if we use the current rounds, then like that there's 30 seconds between like the current round and the next round. It could be like 29 seconds in, and people could guess the number, and we don't want that. What we want is the next round that hasn't been published yet, that no one can know about, that's completely unbiasable and verifiable, and is not known until it gets published. So, and we're going to display that number on our dice. So the next round number is what we want in a roundabout way of saying that. Okay, so rand equals await. So, okay, so now instead of JavaScript, we have to await on stuff. We don't have a context here, but the JavaScript API takes a signal, and that is a signal that you might get from a new abort controller signal. And what you can do with that, if you've got the controller, then you can abort the request. So in much the same way that you'd use context, in JavaScript you use abort controllers and signals. And if you've ever used the fetch API in JavaScript, then you might be familiar with that. But anyway, so instead of context, just remember JavaScript APIs take an options object with a signal property, which you can use to cancel. Okay. All right. So now that we've got this random number, that's great, but it's just a bunch of bytes. It's random bytes. And what we need to do now is we need to convert that bunch of random bytes into a number between 1 and 20 inclusive, because we have a 20-sided dice. Let's do it. You guessed it. Okay, I did this. Honestly, I can explain it. The randomness is encoded in hex. So we're saying, make me a big int from, I have no idea why standard doesn't like this, but big int is a thing. So just don't worry. So give me a big int based on the hex encoded randomness that got returned to me from the API. Mod 20, because we have a 20-sided dice. That gives us a number in the range of 0 to 19, I think, and then we plus 1 because we want we actually want 1 to 20, and then we've got a big int that we need to be like not a big int, so we do a 2-string with base 10, and then we've got our number, so we've got a random number. Amazing. And what we can do, instead of putting 4 here, we can put num here, and I'm just checking my work because I said a lot of words, and in theory that should just work now. So let's go and have a look. Okay, I'm going to refresh this and then roll. Uh-oh. Okay, right. That was weird. Roll. Okay, rolling. Here we go. Okay, now because this is random, there's a possibility it hasn't happened to me yet. It could land on 4, and then you will be like, this hasn't worked. But believe me, it is definitely coming from Drand. 20. Hey, oh no, it's still going. Still 13. All right, okay. There we go. 13 works. Totally works. It's truly unbiasable randomness from Drand, from the League of Entropy nodes, from the mainnet, that is used by Filecoin also, and we are using that to roll a dice in our browser, because why not? So that's cool, and that will do another random number when it comes in. 320. It's up to 30 seconds between successful rolls. 13. Okay, no, it's not a 13 roll, I promise. We'll set that off. But anyway, what we can do though is let's have a quick look at the network tab. Oh, where's my? Can't, let's wait for this one, and then I'll show you the network tab. What's going on? 20. Okay, great. I don't know what happened there. Seems I'm having some interesting internet troubles. Okay, so what happens if we clear these for now? You can see what's happening is it's asking api.drand.sh for the round 101. I think if we look at the website, we are currently on round 100, so we're waiting for the next round. And it just waits there until it comes in, and then it gets transformed into this random number. That's cool. And so the other thing to note is that the JS API also has the watch channel. It's an async iterator, yeah, they're both very similar in their functionality. But that is Drand, and that's how you harness unbiasable, verifiable randomness that Filecoin also uses, and you can use it in your application in Go or in JS, and it would be rad to see clients in other languages as well. All right, that's all I really have to say. If you want to talk to me about Drand, then go ahead. I'm in the Slacks, and I'm Alan Shaw _Alan Shaw on Twitter. I didn't get there fast enough, so I had to make myself private variable Alan, and Alan Shaw everywhere else on GitHub and whatnot. Thank you for listening, and goodbye.